Hi, welcome all to the online classes. I'm Mukesh Bhardwaj. Today going to represent a topic, regression or simple linear regression in the subject statistical methods, BSc Agriculture 5th semester. Regression is basically a word is used to denote the estimation or prediction of the average value of one variable for a specified value of the other variable. The estimation is done by the means of suitable equation derived on the basis of available bivariate data, such as equation is known as the regression equation, and its geometrical representation is called a regression curve. In linear regression or simple regression, the relationship between the variable is assumed to be linear. The estimate of y, say y dash, is obtained from the equation of the form y dash minus y bar is equals to byx, x minus x bar. And the estimate of x, say x dash, from the other equation, usually different from the former of the form x dash minus x bar is equals to bxy, y minus y bar. So the regression equation y on x and in the equation second x on y, the coefficient byx appearing in the regression equation of y on x is known as the regression coefficient of y on x. Simply bxy is called the regression coefficient of x on y. The geometrical representation of linear regression equations, first and second, which I had explained, is known as regression lines. These lines are best fitting straight lines obtained by the method of least squares. So, regression is concerned with the prediction of the most likely value of one variable when the value of the other variable is known. The term regression literally means stepping back towards the average. It was first used by the British biometrician Sir Francis Galton, 1822-1911. Definition: regression analysis is a mathematical measure of the average relationship between two or more variables in terms of the original units of the data. Thus, the term regression is used to denote estimation or prediction of the average value of one variable for a specified value of the other variable. The estimation is done by the means of suitable equation derived on the basis of available bivariate data. Such an equation and its geometrical representation is called regression curve. In regression analysis, there are two types of variables, and they are independent and dependent. First, independent, second is dependent. Dependent variable y, the variable whose values influence or is to be predicted, is called dependent variable. Independent variable x, the variable which influence the value or is for prediction, is called independent variable. In regression analysis, independent variable is known as regressor or predictor or explanatory variable. In regression analysis, dependent variable known as regress or explain variable. Thus, the term regression is used to denote estimation or prediction of the average value of one variable for a specified value of the other variable. The lines of regression, a line fitted to set of data points to estimate the relationship between two variables, is called regression line. The regression equation of y on x describes the changes in the value of y for a given changes in the value of x. The regression equation of x on y describes the changes in the value of x for given changes in the value of y. Hence, an equation for estimating a dependent variable y for x from the independent variable x or y is called regression equation of y on x or x on y respectively. The regression equation of the regression lines, also called the least square lines, are determined by the least square method. The mean is need to be calculated for the group data. The formula can be used as The mean or for group D data is obtained from the following formula: x bar is equals to summation fx upon n, where x is equals to the midpoint of the individual class, and f equals to the frequency of the individual classes, and equals to the number of frequency or total frequencies in a sample. For example, given the following frequency distribution, calculate the arithmetic mean. Marks are given as 64, 63, 62, 61, 60, 59. And number of students: 8 students score 64, 18 students score 63, 12 students score 62, 9 students score 61, 7 school students score 60, and 6 students score 59. So as we observe the table, so this table is called the grouped data or tabular form data. So we need to find out the average for the marks for the following students. Now, how many numbers of students are there? So if we add the number of students, this come out to be 60. So we make a table according to the data given: x, that is the marks, and f, that is the number of students, that is denoted by the frequency. You just do the multiplication of fx 8 into 64, 512, and so on, so on, so on. As for the third column, fourth column, and the fifth column, we do not require the fourth and fifth column. They are just used for the shortcut tricks and methods, but we don't require that. Now, according to the formula, we need to find out the mean for the grouped data. X bar equals to summation fx. So summation of fx we had already done in the table. That is come out to be 3713, and divided by the total number of students, that is 60. So the average come out to be 61.88. What are the merits and demerits of arithmetic mean? Merits: it is rigidly defined. It is easy to understand and easy to calculate. If the number of items is sufficiently large, it is more accurate and more reliable. It is calculated value and is not based on its position in the series. So it is a calculated value and it is not based on the position in the series, whatever the position in the series it is. It is the calculator final value. It is possible to calculate even if some of the details of the data are lacking. Of all averages, it is affected least by the fluctuation of sampling. So whatever the averages we are going to study, uh, whatever the averages we are going to study further, it is least affected by the fluctuations of sampling. It provides a good basis for comparison. So basically the merits or use for calculating the average is that it provides good basis for comparison. Demerits: it cannot be obtained by inspection nor located through a frequency graph. It cannot be in the study of the qualitative phenomena, not capable of numerical measurement, that is intelligence, duty, honesty, etc. So average cannot be a qualitative, cannot be give the qualitative study. It only gives the quantitative study. It can ignore any single item only at the risk of losing its accuracy. It is affected very much by extreme values. It cannot be calculated for open-end classes. It may lead to the fallacious conclusion if the details of the data from which it is computed are not given. Now, the second simple average is median. The median, as the name means, the middlemost item. The median is the middlemost item that divides the group into two equal parts, one part comprising all values greater and the other all values lesser than that item. So one thing is very clear, that whatever the data provided to you, First, you need to arrange that data in the ascending or descending order. And after that, we are going to choose out the middle value among the given data, which departs or which broke the whole data in two groups. One part comprising all values greater and the other part all values lesser than that item. Ungrouped or raw data. So first we are going to find out the median for ungrouped or raw data. Arrange all the given values in ascending order. If the number of values are odd, median is the middle value. If the number of values are even, median is the mean of middle two values by the formula. So when n is odd, median is given by n plus 1 by 2 at th value. And when n is even, average of n by 2 and n by 2 plus 1 term, take the average of these two values and that will give the median. So there need to note one thing, that for the order data, for the odd series, or for the when the data in the odd values are odd, then the median is the data itself present in the series or in the data. But when the even number of data is given to you, then you need to take the average of n by 2 and n by 2 plus 1 position data, and that data will not be lying in the middle or the in the series of the even data provided to you. Example, if the weights of sorghum ear heads are 45, 60, 48, 100, 165 grams, calculate the median. So first of all, arrange these data in the ascending order: 45, 48, 60, 65, 100. Now they are total in 5, that is odd numbers of data is provided to you. So the median will be the n plus 1 by 2th value, that is third value. 5 plus 1 divided by 2 is equal to third value goes to 16. So this will give the 60 is the median in the above data. Now merits of median. Median is not influenced by extreme values because it is a positional average. Median can be calculated in case of distribution with open-end intervals. So first merit is that median is not influenced by extreme values because it is a positional average. Positional average. This is the positional average. Actually, why we are just calling it average? Because we are taking, according to the formula, you had seen that n plus 1 by 2. So basically the median lies on this position, but this position is calculated through the average. So median is not influenced by the extreme values because it is a positional average. Median cannot be calculated in case of median can be calculated in case of distribution with open end intervals. Median can be located even if the data are incomplete. So if the data is incompleted, the median can be located. Yes. Now the demerits. A slight change in the series may bring drastic change in median value. Obviously, whenever there is a change in series, the median or the middle value changes. In case of even number of items or in continuous series, median is an estimated value other than any value in the series. Yes, this is, I had already told you that according to the definition, we come to know that the middle value, median is the middle value. But in case of even number of items or continuous series, median is an estimated value other than the any value in the series. So this is the disadvantage, or you may call it is different from the definition. So it is not suitable for further mathematical treatment except it used in calculating mean deviation. So when we just study the mean deviation in the coming lectures, there we are going to use the concept of median. So it is suitable, it is not suitable for the mathematical treatment except it used in calculating mean deviation. Fourth disadvantage, demerits, is it does not take into account all the observations. Okay. Now the mode. The mode refers to that value in the distribution which occur most frequently, or we can say the most repetitive number in a series or in a data is called a mode. It is an actual value which has the highest concentration of items in and around it. It shows the center of concentration of the frequency in around a given value. Therefore, where the purpose is to know the point of the highest concentration, it is preferred. It is thus a positional measure. Its importance is very great in agriculture, like to find typical height of crop variety, maximum source of irrigation in region, maximum disease prone paddy variety. Thus, the mode is an important measure in case of qualitative data. So, it is a measure important for case of qualitative data. Computation of the mode for ungrouped or raw data. For ungrouped data or a series of individual observation, mode is often found by mere inspection. Example, find the mode for the following seed weight: 2, 7, 10, 15, 10, 17, 8, 10, 2. These are the some weights of the seeds given to you. So, what is the mode? A mode is the, as we according to the definition know that, the number which repeats, or the number frequency of the repetition of number is which number is larger is known as mode. So if we just do the inspection of the series or the weights given to us, we find that 10 is repeated thrice, where 2 is repeated twice, 7 once, 15 once, 17 once, 8 once. So 10 repeats thrice a time. So the mode for the given data is 10. In some cases, the mode may be absent, while in some cases there may be more than one word. Example: 12, 10, 15, 24, 30. What is the mode in this series? By inspection, we observe that all the digits are given only once. No repetition of any digit is there. So we say that there is no mode available or no mode in this series. Now, for example, second, 7, 10, 15, 12, 7, 14, 20, 24, 20, 7, 20, 10. So as we observe the series, we find that 7 is repeating thrice a time, and 10 is repeating thrice a time, and all other values are not repeating more than thrice. So the modal values are 7 and 10, as both occur thrice a time. So you cannot decide or you cannot directly say that 7 alone is the mode or 10 alone is the mode, because both the numbers occurs uh, thrice a time, that is equal in frequency. So these two are the modes. Grouped data. For discrete distribution, see the highest frequency and corresponding value of x is mode. For discrete distribution, that is grouped data or the tabular form data is given, then the mode is directly can be calculated by observing the frequency which is directly given to you. Weight of the sorghum in grams: 50 gram. Number of ear had 4, 65 6, 75 16, 88, 95 7, 104. So 75 is repeating 16 times, which is very high frequency other than the other weights. So the maximum frequency is 16. The corresponding value, the corresponding x value is 75. Therefore, the mode is equals to 75 grams. Now, continuous data or continuous distribution. Locate the highest frequency. The class corresponding to that frequency is called the modal class. Then apply the formula. Mode equals to L plus Fs upon Fp plus Fs into C, where L stands for lower limit of the modal class, Fp stands for the frequency of the class preceding to the model class, Fs is the frequency of the class succeeding to the model class, and C equals to the class interval. So, if any data is provided into the form of class distribution or continuous distribution, and locate the highest frequency class corresponding to that frequency called the modal class. So then apply the formula like this, and we need to find out the lower limit of the modal class. First of all, we are going to find out the modal class. For example, just in the example, you see that a frequency distribution of weights of sorghum ear heads given in a table, calculate the mode. Weights of ear heads 60 to 80, 22, 80 to 100, 38, 100 to 120, 45, 120 to 40, 140, 35, 140 to 160, 20. So, as by observing the table, the number of ear heads 45 is more for the range 100 to 120. So, this is decided as the modal class. First of all, this is decided as the modal class. Okay. After deciding the modal class, now put everything according to the formula. So L is the lower limit or lower range of the model class. So 100, L equals to 100, and F equals to 45. That is the highest frequency. C equals to the difference between the model class. That is 120 minus 100. It come out to be 20, and M equals to 60. M equals to 60, and Fp equals to 38. That is the frequency preceding to the or to the model class 38, and to the 35, that is further further model class value. Now put all these values. 100, that is L, plus lower frequency 35, 38 plus 35 into 20. So the answer come out to be 109.589. So this is the mode. Now quartiles. Quartiles are just like a percentile and all that. Percentile means that you divide into the 100. So similarly to that, the quartile divide the distribution into four parts. There are three quartiles. The second quartile divides the distribution into two halves and therefore is the same as the median. The first lower quartile Q1 marks of the first 1/4, the third upper quartile Q3 marks of the 3/4. It may be noted that the second quartile is the value of the median and the 50th percentile, raw or ungrouped data. So, for finding the quartile deviation or quartile division for raw or ungrouped data, first arrange the given data in the increasing order and use the formula for Q1 and Q3. Then quartile deviation QD is given by QD is equals to Q3 minus Q1 by 2, where Q1 is calculated as n plus 1 by fourth item, and Q3 is equals to 3 n plus 1 by fourth item. Okay. So first you calculate the Q1 and Q3. After that, quartile deviation is the difference between Q3 and Q1 divided by 2, that is the average. Now these are the some questions or the quiz related to the part we had covered. So the middle value of an ordered series is called second quartile, fifth decile, fifth percentile. all the above. So the middle value of an order series is called, it can be second quartile, it can be fifth decile, it can be fifth percentile. That's mean the D option, all the above, is correct option. For a set of values, the model value can be unimodal, bimodal, trimodal. I'm repeating the question once again. For a set of values, the model value can be unimodal, bimodal, trimodal. It can be anything. So all of these, all of the above. The D option is correct. Third is mode is suitable for qualitative data. Yes, we had studied the merits and demerits, where there we had to find that mode is suitable for qualitative data. Yes, it is true. Decile divides a group into 10 equal parts. Yes, obviously decile, percentile, I had already told you that it divides into 100 parts. So decile divides the group into 10 equal parts. True. Mean is affected by extreme values. Is it true or false? Yes, is it true? Mean is always, that is average, is always by the extreme values. Geometric mean can be calculated for negative values. Yes, it can be calculated for negative values. Now, these are some theoretical questions which you need to write by your own understanding of the topic. Define mean and median. For what type of data mode can be calculated? Explain how to calculate the arithmetic mean for raw and grouped data. Explain how to calculate median and mode for grouped data. So this is all about the mean, median, modes. And now we are going to start with another topic. So we will start in the next lecture, that is the measure of dispersion, range, variance, standard deviation, coefficient of variation, computation of the above strategies for raw and grouped data. So this will be started in the next lecture. And just for today, thank you. Thank you to all of you. Now, measure of dispersion. In statics, dispersion, also called variability, scattered or scatterness or spread, is the extent to which a distribution is stretched or squeezed. Common example of measure of statistical dispersions are the variance, standard deviation, and interquartile range. Dispersion is contrasted with location or central tendency, and together they are the most used property of distributions. So a measure of statistical dispersion is non-negative real number, that is zero if all the data are same, and increases as the data become more diverse. Most measures of dispersion have the same units as the quantity being measured. In other words, if the measurement are in meters or second, so the measure of dispersion. Example of dispersion measures include standard deviation, interquartile range, mean absolute difference, also known as Gini, mean absolute difference, median absolute deviation, average absolute deviation, distance standard deviation. These are frequently used as estimators of scale parameters, in which capacity they are called estimates of scale. Robust measures of scales are those unaffected by small number of outliers and include the IQR and MAD. All the above measures of statistical dispersion have the useful property that they are location invariant and linear in scale. This means that if a random variable has dispersion that is ignored a proceeding negative. Other measure of dispersion are dimensionless. In other words, they have units even if the variable itself has units. Now, to understand the dispersion, the averages are representatives of the frequency distribution. We had seen the or we had studied the various averages, but they fail to give a complete picture of the distribution. They do not tell do not tell anything about the scatterness of the observation within the distribution. Suppose that we have the distribution of the yield. Suppose that we have the distribution suppose that we have the distribution of the yield per plot, kg per plot, of two paddy varieties from 5 plots each. The distribution may be as follows. Variety first and variety second in different 5 plots or in different 5 beds are given. When we are going to take out the average of these 5 distribution, it can be seen that the mean yield for both varieties is 42 kg, but cannot say that the performance of two varieties are same. There is a greater uniformity of yields in the first variety, where there is a more variability in the yields of the second variety. The first variety may be preferred since it is more consistent in yield performance. Uh, from the above example, it is obvious that measure of central tendency alone is not sufficient to describe a frequency distribution. I'll let you give one more example or a live example. Suppose if I'm talking or if I'm taking an example of three families. Three family are having the different family members. The number of family members are different, and their incomes of each family members are also different. And suppose if we know that, or if we want to calculate it, the average income of each family, then it is found to be equal in all the respect. So where there is a variance or where there is a difference in the family members of each family, and there is a variation in their income also, but the average come out to be the same. So we can directly say that the average alone cannot give or not sufficient to describe the frequency distribution. In addition to it, we would have a measure of scatterness of observation. The scatterness or variation of observation from their average are called the dispersion. So, what do you mean by the dispersion? The basic mean of or the basic definition of the dispersion is the scatterness or variation of observation from their average are called the dispersion. There are different measures of dispersion like the range, quartile deviation, mean deviation, and the standard deviation. I had already told you. Now, what are the characteristics of good measure of dispersion? An ideal measure of dispersion is expected to possess the following properties. It should be rigidly defined. It should be based on all the items. It should not be unduly affected by extreme items. It should lend itself for algebraic manipulation. It should be simple to understand and easy to calculate. These are the some good characteristic of measure of dispersion. Entropy and the dispersion are almost same word. Entropy, while the entropy of the discrete variable is location invariant and scale independent, and therefore not a measure of dispersion in the above senses. The entropy of continuous variable is location invariant and additive in scale. If Hertz is the entropy of continuous variable Hz and Z, then there are two measures of dispersion, variance and variance to mean ratio. So entropy is the degree of randomness. For categorical variables, it is less common to measure dispersion by a single number. The qualitative variation, one measure that does not or that it does so, is the discrete entropy. Now, the first measure of dispersion, that is range. It is the simplest possible measure of dispersion and is defined as the difference between the largest and the smallest values of the variable. In symbols, range is written as largest minus smallest. In individual observation and discrete series, largest and smallest are easily identified. In continuous series, the following two methods are followed. As we had discussed, the data or the observations are given in basic three type of categories. First is the raw data or ungrouped data. Second is the frequency distributed data. And third is the class range frequency distributed data. So in raw data and ungrouped data, the range calculation is so easy. By the observation, you just subtract the largest value to the smallest value and you get the range. But in the case of frequency distributed data or in the class frequency distributed data, you need to do the calculation somewhat by choosing the higher frequency as the largest and the lowest frequency as the smallest. Now, for example, if you take an example for the raw data, a series or observation is given in front of you 8, 9, 8, 10, 10, 11. So, by observing this, the highest value is 11 and the lowest value is 8. So, the range is given as 11 minus 8, come out to be 3. Now, if I'm talking about example 2, the distribution or the data is given in the frequency class distribution range 60 to 63. The size is of 60 to 63, having 5 number of frequencies 62 to 66 and so on. So we have to choose the upper boundary of the highest class and lower boundary of the lowest class. So the highest boundary having the highest number is 75 and the lowest class is having the smallest number 60. So the range is given as 75 minus 60, that come out to be 50. Now, merits and demerits of range. It is simple to understand. It is easy to calculate. In certain types of problems like quality control, weather forecast, share price analysis, etc., range is most widely used. Demerits. It is very much affected by the extreme items. It is based on only two extreme observations. It cannot be calculated from open-end class intervals. It is not suitable for mathematical treatment. It is a very rarely used measure. Now, standard deviation. It is defined as the positive square root of the arithmetic mean of the square of the deviation of the given observations from their arithmetic mean. So the standard deviation is having the definition in accordance to the formula. So analyze the formula carefully and remember the formula very carefully and work on the data and the observation given to you and put the all values of the data in the formula and get the solution for standard deviation. Here standard deviation formula for the raw data is given summation x square minus summation x to the whole square by n upon n minus 1 under the root. This formula is for the raw data. Now this is for the discrete data and the third formula is for the continuous type of data. So please note down the formulas according to the different types of observations or data provided to you, because standard deviation is totally depending on the formula and the calculation. And now we are moving for the some examples. This is the example given for the raw data and you need to find out the standard deviation. So as per according to the formula, we are going to create the table, arrange the data in the columns, and according to the formula, create the table, introduce the columns, do the totaling, and put all the totaling because the summation words are to be used in the formula. So here we require the sum. So put the summation and divide it by the number of observation. You are able to get the solution. So the standard deviation for the above example come out to be 12.25 grams. Now the standard deviation for the frequency distribution type data or discrete distribution type data, the seed yield in grams 3, 4, 5, 6, 7 and the frequency 4, 6, 15, 15, 10 is given to you. Now use the formula, create the table, and according to the formula, introduce the column in the table and do the summation of all the data in the last row, that is total. And when we add the frequency, it come out to be 50, that is total number of observation. The value of n is 50. Put all the values in the formula. Finally, you got the solution which come out to be 1.1677 grams is the standard deviation for the given discrete distribution type data. Now, for continuous type distribution data, the frequency distribution of yield of the 50 shisham plants are given below. In the range of 2.5 to 3.5, 4 plants. In the range of 3.5 to 4.5, seed yields in grams is given by 6 plants. And similarly, in the range of 4.5 to 5.5, in the range of 5.5, 6.5, and in the range of 6.5 to 7.5. Now, according to the formula, create the table, arrange the table in the table, arrange the data in the table, and according to the formula, create the columns and do the totaling in the last row and put all the values in the formula. Have a look for this. And while putting and doing the calculation, care must be taken And when you put all the data in the formula for the standard deviation for class distribution type data, for the above example, the standard deviation come out to be 1.1677. So this is all about the standard deviation, and we had seen the examples related to the standard deviation for all the three types of data. Now the merits and demerits of standard deviation. Merits, it is rigidly defined and its value is always definite and based on all the observation, and the actual sign of deviations are used. As it is based on arithmetic mean, it has all the merits of arithmetic mean. It is the most important widely used measure of dispersion. It is possible for further algebraic treatment. It is less affected by fluctuation of sampling and hence stable. It is the basis for measuring the coefficient of correlation and sampling. Now demerits. It is not easy to understand and it is difficult to calculate. It gives more weight to extreme values because the values are squared up. As it has an absolute measure of variability, it cannot be used for the purpose of comparison. So these are the merits and demerits of standard deviation. Now we are going to start with variance in the next lecture. So thank you all for today's lecture. We will discuss variance, coefficient of variance in the next lecture. Thank you all.